Hi everybody, today we are going to do a broad introduction to functions. So we're going to start by talking about what is a function. So a function is a relationship where every input has exactly one output. So I'm going to repeat that because it's so important. It's a relationship where every input has exactly one output. So you can see like a little visual of it over here. So we have an input, we put it into our little function machine, and it will spit out some output. So in our equations, the input's going to be x. So we take x, we plug it into our function equation, and it spits out a y value. So x, y, input, output are totally interchangeable. We also will see the words independent variable and dependent variable. The input is called the independent variable. You can remember that because it's input and independent. The reason why we call it this is it's the thing that we choose. We can pick whatever we want to put into our function. The dependent variable is going to be that output or the y value. The reason why it's called the dependent variable is because it depends on the value we pick for our x value. And you'll also see x and y referred to as domain and range, which we will talk about later on in this video. So remember, the most important definition of a function is that every input has exactly one output. So we're going to talk about that on the next slide. How do you recognize a function, and what does it mean to say every input has exactly one output? I like to think of it as birthdays. Every person has exactly one birthday. Like there's no one on earth that has two birthdays, right? You have exactly one birthday. That kind of represents a function. So if you look here, our inputs all have exactly one output. They all have exactly one birthday. Now, if you look at what's happening here, this person has birthday C, and this person also has birthday C. It's okay for multiple people to have the same birthday. It's okay for different inputs to have the same output. But what's not okay is this situation over here. So if you look over here, person 3 is claiming to have two separate birthdays, and that's just not possible. So it's okay for two different inputs to have the same output, but it's not okay for the single input to have two different outputs. So the reason why we care about this is if we're using a function, we want to get the same answer every single time. If I plug in 1, I should always get C. It doesn't make much sense if sometimes we get one answer and sometimes we get a different answer. So that's why they say it's exactly one output. So if you ever kind of forget which one is which, think of birthdays. Everyone has exactly one birthday, but some people have the same birthday. So you might see that different inputs have the same output, and that's totally fine. But this is not okay. You can't have one person with two different birthdays. Here's a different representation of two relationships between numbers. One is a function and one is not. So let's talk about why this one is a function. If you look at all of these numbers, none of them repeat. So every input has exactly one output. But if you look at these numbers, there are some repeating numbers here. So you'll notice we have a 1 here and a 1 here. So this input of 1 gives us an output of 2, but our second input of 1 gives us an output of 5. So that's like saying this person, one day they say their birthday is in February, but one day they say their birthday is in May. So we have a single input that has two different outputs. So this is not a function. So it's okay to have repeating y values. It is never okay to have repeating x values because that means that they have different outputs. Okay, let's look at some pictures of graphs and see if we can determine whether these are functions. So this every input has exactly one output. You can test for that with what's called the vertical line test. So the way the vertical line test is, imagine you have a vertical line. I have this lightsaber, so this is my vertical line. If you run your vertical line, and you could just use your pencil, across your graph, At any point, your graph should only be touching it one time. So if I run my lightsaber across this graph, it's only touching my lightsaber at one point. So again, if I look at it like this, okay, here's a vertical line, it's only touching once. Here's a vertical line, it's only touching once. Here's a vertical line, it's only touching once. This passes the vertical line test, so this is a function. And really what it's saying is that for every input, there's exactly one output. Now, if you look at this example, let's try the vertical line test again. As soon as I get to this point, I can see that this line is hitting my vertical line twice. So as soon as that happens, it actually fails the vertical line test because it's crossing twice. So really what it's saying is for this input, there's actually two outputs. For this x value, there's two y values. And it's happening over and over, right? For this x value, there's two different y values. For this x value, there's two different y values. So this is not a function. So that's how you can test to see if something is a function graphically. So you can sometimes do it by looking at a table of values, or you can use their vertical line test if you are given a graph. So remember, it can never cross your vertical line more than once. Okay, so now we're going to revisit those words domain and range. I said that the domain is associated with the x values and the range is associated with the y values. By definition, the domain is the set of all possible x values or inputs, and the range is the set of all possible y values. So we're going to look at a few different graphs and a few different sets of numbers and see if we can determine the domain and range. They're pretty much asking, hey, what are all the x values and what are all the y values? So first, we're going to find the domain and range of this set of numbers. So these, imagine, are just coordinates. They're just points on a graph. So really, for the domain, we just go through and we list all of the x values. That's it. It's just the set of x values, or the input. It is nice to list it from lowest to highest. So our lowest number is 2, 3, 4, and then 5. So these are all of the possible x values from the function that we're given. Now remember, range is just all of the possible outputs or y values. So you literally just go through and list all the y values. So you'll notice that our smallest number is -1, and it's listed twice. You only need to list it once. If you've listed it, you said, hey, this number is part of my range. And then we have 0, and then we have 2. So those are all of the possible y values from this function. Okay, so the domain, it's just asking you to list the x values. The range, it's asking you to list the y values. We can also do that by looking at a graph. So if you have a graph with, this one has 4 coordinates, it's sometimes nice to first list out the coordinates. So we have the coordinate -3, -3, -1, -3, 1, -3, and 3, -3. So remember, the domain is just a list of all of the possible x values from lowest to highest, so -3, -1, 1, and 3. And the range is just a list of all of the possible y values. You'll notice that all of the possible y values are the same, so our range is just one single number. It's just -3. Okay, go ahead and pause the video and see if you can list the domain and range of these two functions. Okay, go ahead and check your answers. For the first one, your domain should be -6, -4, -3, and 7, all of the x values, and your range should be 0, 1, 2, and 11, all of your y values from lowest to highest. For part B, I listed the coordinates here. Your domain is all of those x values, and your range is all of the y values. You'll notice that 4 is stated twice, but you only need to write it once, and so is 2. So your range is only 3 numbers, even though you have 5 coordinates, so 0, 2, and 4. Okay, let's do domain and range again, except in a different type of format. Here we have what looks like an XY table, which it really is, but let's call it an input-output table. The input, of course, is the X. The output, of course, is the y. And here's our given function, y equals negative 3x plus 4. And we know that we've worked with functions like this before. It should look pretty familiar. We're just giving it a different name of a function instead of an equation. So we're going to see if we can complete the table. We know that we complete tables by substituting these x values into our equation to find the y value. So we're going to substitute over here. So we're going to take our first input, which is negative 2. And we're going to say y equals negative 3 times negative 2 plus 4. So y equals 6 plus 4, which is 10. So for the input of negative 2, I get an output of 10. And we can do the same thing for negative 1, 0, 1, and 2. Negative 3 times negative 1 plus 4. So negative 3 times negative 1 is positive 3 plus 4 is 7. Okay, let's do 0. Negative 3 times 0 is 0. 0 plus 4 is 4. Negative 3 times 1 is negative 3. Negative 3 plus 4 is positive 1. And last, negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. So we've completed our input-output table, and now we just need to list the domain and the range. So remember, again, our domain is just the list of all of the possible x values, and our range is just the list of all the possible y values. We do need to put these in order from lowest to highest. So we have negative 2, negative 1, 0, 1, and 2. And then for the range, our smallest is negative 2, and then 1, 4, 7, and 10. All of the possible x values and all of the possible y values for this set of data. Okay, go ahead and pause the video and give this last problem a try. Please complete the input-output table for this new function and see if you can state the domain and range. Okay, let's check our solutions here. So I know this one is a little bit tricky because we have this fraction, but if you substitute 0, this fraction disappears, so it's negative 6. Here you can see if I'm trying to do 1/2 minus 6, I'm going to rewrite 6 as 12 over 2, so there's a common denominator. 1/2 minus 12 halves is negative 11 halves. Here, remember, when you multiply a fraction to a whole number, we do 2 times 1 divided by 2, so it's just 1. 1 minus 6 is negative 5. Here, this is 3 halves minus 12 halves, which is 6 with a denominator of 2. 3 minus 12 is negative 9, so it's negative 9 over 2. And here, we do 4 times 1 divided by 2, and 2 divided by 2 is 2. 2 minus 6 is negative 4. So there's our outputs, or our y values. So our domain is the list of all of the possible x values, and the range is the list of all of our possible y values. All right. That is all for today's lesson. Thank you so much for watching.